Hello, this is Master Ayush from Silent Modern Mons, and this is our submission to Manipal Hacakathon 2022. And our selected problem statement is IoT02 Smart in Campus Car Parking System. Let's go with the problem statement. So this is the problem statement. This is the solution factors that I factorized from the problem statement. So, first of all, how will you know if the car is in parking slot? Second one is if you know the car is in parking slot, then how will you transmit the data to the cloud? Third one is then what's on the user side? Fourth one is are you sure your mechanism is optimized? And fifth, what will be the estimated cost? So let's just all of them. So first is how will you know if the car is in parking slot? Using microcontroller and sensor. But how? So here I will present the Tinkercad project that I created. So this is my Tinkercad project I have created on tinkercad.com. So this is Arduino Uno, and it is connected to few of the parking slot. These are the slots that I created. One Arduino can take six parking slot. Okay, so let's test them. Okay, so this is ultrasonic sensor which detects the object in range, and it also provides the how much distance from the object and ultrasonic distance. See, it provides everything. And here we have used Wi-Fi module, and other thing is the board for the whole to organize things, to organize all wires. Here, the ultrasonic sensor are detecting and sending data back to the Arduino. So let me show you the code. So this is for setup in 8266, and here it is. As you can see, let me start simulation. See here, as you can see, the data is getting updated every second. Every data is getting pushed every second. So let me show you the, and for this test purpose we have used ThinSpec IoT. This is like for IoT purpose platform, and here you can see we have four: field 1, field 2, field 3, field 4, and this four represent this four slots. And let me show you the example. So here we have the first slot, and in the first slot we are going to set this to 56 semi, and here you can see the field 1 is getting 55, and it will redirect here in a few seconds. As you have seen, distance 1 55, and we also get the time 10 23 25 36. Okay, and the fourth all are getting updated at every second. So this is basic and working parking slot model. So let's go to our third question. So now we have the circuit and models are ready for the parking slot detection. So then what's on the user side? Wait, server architecture, right? So let's see our server architecture for the user. So here is the all model the circuit models. Then from the ESP8266, we are at every 10 seconds we are updating data on our AWS EC2 server. So how will that work? So we are going to create a server backend using Node.js as a compiler time. Then Express for server framework, and database for MongoDB for database. This is a basic man backend, and we will it will be deployed on EC2 server. And for the client side, it will use React Native, Android slash iOS. It will be available on both, and client side will request to the AWS EC2 server for the parking slots. On using ESP8266 and server, we are going to update at every 10 seconds on a EC2 server. And from the client side, we are going to request, and we will receive the parking slot details. So first of all, let's visit the. It will start from here. So using Google Map APIs, we will detect the location of the user, and we will see if the user is in campus or not. If he entered campus or not. So after detecting the location using AWS SNS, a simple notification service, we will send a notification to the client kit that these are the things, and what will be the so you sorry for the interrupt. So using SNS, we will the SNS will have the data of AWS EC2, that how many parking slots are left. Then we will send the notification to the client side, and client side will receive the notification and will request the data again from the AWS EC2 proper datas, and it will receive the data. And by the receiving the data, we will use Google Map area API again to roadmap for the roadmap functionality to available slot. Like we will show the road to the that direct slot. So our third question is solved. So let's go to our presentation. Okay. So are you sure your mechanism is optimized? So we got better options. Let me show you. So I will take you to my Figma slide. Okay. So let's assume this is a sensor, and this is like a normal mechanism. If you search Parkin's slot system, then it will come up. So here we have some problem. If we are using ultrasonic sensor, then if we put the sensor far away, then it might not get the object details easily. So, and if we put it too close, then we might have a possibility that car will hit the sensor and will broke it. So what might be the solution? So we came up with the solution that uh, using ultrasonic sensor we will put it. So this is our solution that we created. So this is ultrasonic sensor, and it will detect if the car is under it or not. And the we will also put the mechanism that if we hit the if it won't hit the surface, so we won't have any problem. And this is the graphical picture of that, that here is the sensor and here is the car. For this graphical, it is too much depth, but for the ultrasonic sensor it won't be that much depth. So let's go to our fifth question and last one. So what's the estimate cost? And after knowing that, you will say, wait, really? So let's go to our cost. Wait. Okay. This is our cost. These are the main component that one parking slot will require: a U31 Wi-Fi module, ESP8266, U5 one word Arduino R3, and one ultrasonic sensor. Okay. So and we can use up to 6 ultrasonic sensor in one Arduino with one Wi-Fi module. So if we charge this, it will be about 200 per parking slot, using this only mechanism, these main components, and 100 miscellaneous and estimate that wires and mechanism and all. This is mechanism estimate, and it will be 300 total per piece. So this conclude our submission for the Manipal Hackathon 2022, and we Silent Modern Mons appreciate the effort by the Manipal team.